Bismillahirrahmanirrahim. Good afternoon. Assalamu alaikum. Today we'll have a topic on the fuzzy logic. And the first slide is about the introduction of fuzzy logic that we'll start with. And basically, what is fuzzy logic? Fuzzy logic is a multi-valued logic that recognizes more than simple truth or false value, represented in degree of truthfulness and falseness with the value range between 0 to 1. That is 0 means absolute false and 1 absolute truth. Consists of theory of fuzzy sets are based on idea that all things are up to certain limit and works on fuzzy sets that indicate the maximum limit or degree of an element. Example, temperature, height, distance, beauty, and so on. With the statement like Tom is a very tall guy, or the motto is really hot. So not actual numbers, but in terms of what we call linguistic statements. Okay, people normally depends on common sense to solve problems like we do in our normal day of life. Fuzzy logic provides a systematic representation of the uncertainty and impression of vagueness that we normally deal when we do our day-to-day dealings, or day-to-day manual control of certain things like aircon and so on. So and it's very close to how fuzzy logics move around. Uncertainty means not possible to determine true or false. A person is possibly 25 years old. This is a statement of uncertainty, or impression, not as precise as it should be. This person is around 25 years old. These are the things that normally we would deal with in our daily life. And this is closely related with how fuzzy logic is developed. Okay, another example. This is sort of non-fuzzy. Yeah. Tall, non-tall, straight, two values. In this case, it's about not very tall, or in this case, definitely tall. So it's in between the not tall and tall as well that comes up with what we have, this fuzzy logic variables. Okay, the history of fuzzy logic basically it's 1964 of Tizadeh, an Iranian state in America. He introduced this concept of fuzzy sets to his paper, and then broadened the foundation of fuzzy set theory from 1965 to 1975. In 1970, the fuzzy research group formed in Japan to deal with this and to expand the research on fuzzy logics and so on. In 1974, the first fuzzy logic steam engine controller was developed by Mamdani, University of London. So we have all these aspects of the Mamdani rules later, where we will mention to you later. And then we have started the industrial application of fuzzy logic mainly in Japan from before until now, and then later comes application in many other fields. Okay, this is a very brief history of fuzzy logic. There's so many things that happen in between anyway, and even until now. And a lot of applications in fuzzy logic in your day-to-day rice cooker, camera, washing machine, okay, and many other things, aircon and things that you're using day to day with some fuzzy logic elements inside it, which we may notice or not notice at all. Okay. How about in chemical engineering? Yeah, so that's something that can be used and definitely possible for modeling side and for control and for many other aspects. May not be that extensive usage in the real world, but in terms of simulation, of course, it's very extensive. In the real world, there may be some little parts of fuzzy logic being used for combination with other methods like neural network and model-based systems. So it's possible it's going to come up also very fast in the future, and it will be more evident in the years to come when AI is being introduced very strongly on the theme of IR4 concepts. What are the elements of fuzzy logic? Basically, fuzzy logic involves the process of fuzzification, and then what we have the inference mechanism or the fuzzy inference system part. Then we have the rules or rule-based algorithm part. Then we have the defuzzification part to go back to the actual values. Okay, fuzzification, what we do, we change the inputs normally in the normal numerical values. The case values, we call it in fuzzy logic terms, change to fuzzy sets. So that's one issue. And then we have to also define the inputs to the process. We are talking about process or anything that we're trying to simulate or use fuzzy logic. So what are the inputs we want to be included into the fuzzy control or modeling or whatever. Okay, for example, the error, one input, change of error as another input. So you decide them, and then only you do the fuzzy sets, fuzzy sets conversion. Okay, the next step, the inference mechanism or the fuzzy inference system. Basically, we develop the inference system which consists of the membership functions. Okay, once we decide the fuzzification, we got the linguistic variables and the range of values and so on, and we decide what sort of membership function we want to represent the fuzzy sets. The normal one is a triangular membership function or the trapezoidal membership function, also the Gaussian membership function. These are the normal common ones. There may be some other variants, but these three are the most commonly one used in our fuzzy logic simulation and in the control side. It can be also known as a function to define the membership value of the fuzzy set from the real value after we convert. So these are the fuzzy linguistic variables, and what are the membership values we define either in triangular, trapezoidal, and Gaussian. We have to set the rules and so on. We'll see the examples later. And then we decide the rule-based algorithm, which is the basic core of the fuzzy logic part. Okay, the rule-based algorithm consists of several linguistic variables that are combined to form a set of values. The linguistic variables are the word or sentence in natural language. Okay, and basically like height, speed, and so on. These are the linguistic variables, okay, that we are going to use in our fuzzy logic definition and so on. And then the rules are used from an if and then what happened. If this, then this happen, or if this and this happen, or if this and or happens. For example, if temperature is high, then valve is open. Or if temperature is high or changes that or and change of temperature is low, then what happens? Valve open, valve slightly open, and so on. So those are these linguistic, the variables and the linguistic values in terms of high, open, small. These are all the fuzzy logic issues that are different from what we've been used to in the real definite numbers. And this is the rules. We can put them into this what we call the FAM fuzzy associative matrix as well. Sometimes named like this. This is a nice way of putting the rules, set rules in this form where you have the input one, input error, the change of error. Okay, and these are the linguistic values that we like to define: negative, zero, positive. So if error is if the error this and this one is the output, whatever output you want to happen. So if okay, so in this case, if the error is in this case negative and the delta E is also the delta E is negative and the error is negative, then we get a positive. A P means a positive output. If the change of delta E is 0, error is 0, then we get 0. So that's how we read it. If delta E is positive and E is delta E is positive, E is positive, then we get a positive output. So we have these different rules here. Okay, in this case we have since we have all the sets, so we have basically 9 rules in this case to work with. Okay, then try the if and then statement here. Okay, so from here we can produce the if and end statement. Okay, if in this case we end, but we can also have if or rules if you would like to have. But this is a simple way of putting it in terms of table. It doesn't have to be. You don't have to put this in terms of this matrix, but it's a simple way to visualize the matrix, especially before you start to define the fuzzy limits and so on. These are the rules that you like to first imagine and put it in a table and then redefine it later. Okay, then the next step is to defuzzify it. You see, okay, convert the fuzzy set into real data or the real values, basically, the one that we are working day to day. And we can use the centroid method or center of gravity, center of gravity or center of area approach to obtain the Cliff's value to be applied to the process. So there are a few methods to do this. These are some of the common methods that we use for defuzzification. We'll see later. Okay, for example, calculate the center of gravity or center of area, break the if and then statements. Either we have the n value, we use minimum to define the n value, or maximum for the or value. Then we draw the statement input and output based on the membership shape given depending on the shape, and then combine them, the output shape, into the step 3 to calculate the center of gravity, center of area. Basically, because every time we have different rules because of the fuzzy nature of the process. So not only one rule is fired, but there are many rules at the same time. Which means there are many different possibility for the output. So how do we decide them? So this is what we call normally to the process of aggregation, and then we combine them and then do the differentiation either through any of these methods to get one value. At the end, we need one value for the output. You cannot have many output values, so we have to basically aggregate or combine through this process of what we call diversification using the different methods. This is just an example of center of area, but you also normally can also use center of gravity formulas. Okay, so basically we're going to use fuzzy logic normally on using MATLAB through the fuzzy logic toolbox. So we'll have all these different parts that we need to use in the fuzzy logic toolbox. Okay, the fuzzy inference editor, the membership function editor, the rule editor, the rule view, and the surface view. Okay, maybe the rule surface an optional part. That is the major parts, the steps that we have to follow is what we have seen. Okay, basically in this we need, as I said just now, the face editor, membership function editor, the surface viewer, the rule viewer, and rule editor. These are tools that will help us to design the fuzzy logic system. Okay, and the fuzzy inference system is basically once we decided the inputs, okay, and the outputs. In this case, we're talking about service and restaurants, so the service and the food. Then we decide how much tip we want to give. So we will have to decide what sort of aggregation method we want and so on in the MATLAB toolbox. Of course, it's just what you call it's user friendly. We can just use what we want, but we have to understand properly the basic before we just use it blindly, so that we get a good meaningful answer. Just like we do, we need to understand the basic and what we are choosing for the inputs, outputs, and the range and so on. So in this case, 2 inputs, 1 output, and we have decided that we have 3 rules. Okay, for the fuzzy logic system. So these are defining the inputs and output variables, and is adjusting the inference functions that we would like to use in the combination for the inputs to get the outputs. Okay, and these are the names and inputs, outputs, and so on. Whatever we define in this part, we call the fuzzy inference system editor. Okay, this is what we designed for the membership function. What sort of membership we want for all of these variables? Okay, for example, this a service. What membership functions we need to define for the linguistic variables poor, good, and excellent. So in this case, for poor, this is the membership function we would like to define. Okay, for good, it's going to be this function, Gaussian sort of thing. For accident, it's going to be this function, a trapezoidal function sort of. So we have to decide the membership function we want for each of the variables, the linguistic, basically the linguistic variables that we have choose. Okay, the linguistic values that we have choose. How is the membership function, and then we have to decide the range, what sort of range we are going to talk about in terms for each of the variables. In this case, 0 to 10. And so on. So we have to decide and then define them in the MATLAB function editor. Okay. Select and edit the attributes of the membership function, and this edit the values of the current values and name them whatever name that we have in terms of poor and what is the membership function. And these are the rule editors that we have decided for the rules in the system. 3 rules. If service is poor or food is rancid, then tip is cheap. Okay, if food is not so good, means if service is good, then tip is average. That's it. Without talking about the food. Service excellent or food is delicious, is an or, then tip is generous. So we define this to here, to all this, the software that's given in MATLAB, and then create the edit the rules. Okay, normally when we put n, we use the minimum for the aggregation. For all, we use the maximum for the aggregation when we can get the output later. So all this, once we create them, it comes out in this way. 3 rules. Okay, the rules and all that depend on the data we have, the experience we have. Of course, the more rules we have, the better going to be the output. The robust will be output, the better will be the results, and so on. But that's why the fuzzy logic will depend on the type of experience that we have. The more we have, the more data we have, the better the fuzzy logic is going to be. Just like neural network, more data, the more robust the neural network. The same thing also with fuzzy logic. The more data sort of thing, the more understanding of the system, the more experience we have, the better and the more robust, more precise the output of the fuzzy logic will be, or the result of the fuzzy logic will be. Okay, these are the rules viewer that you have. This is a nice way to see what's happening when we run the system. In terms of how the input variable is used in the rules, we decide certain service is 3 or 4 equals to 8 to see how it changes and how the output come after aggregation. So this is how the inputs behave and how the output behave if you change the input values. Okay, from the normal value, the creeps of definite value, to the fuzzy logic, fuzzy rule, fuzzy values. Okay, pass through the process of fuzzy logic algorithm, and then come out with the output after aggregation and diversification, so we can visualize how it behaves. So you can change them as you go about and see how it changed. This is surface rule in terms of if you have 2 input output, you have 2-dimensional, you have 2 inputs and 1 output. You have 3-dimensional in terms of how the service and food change and change the tip, which is the output part. Okay, this is another optional part, but it's good to, from here we can visualize a few things and see how robust our system, and we can do a sensitivity check, test our systems, and so on. So this helps in our designing our fuzzy logic system much better. We can go and forth and do the changes as time goes by. Okay, and so this is again shows output first phase as you change the inputs. Okay, the inputs changes, see how the output changes. So as I said before, this is very useful for us to do in sensitivity test to check the robustness of our system. If we need to, then we may have to add more rules. We need so, we may have to add the inputs, extra input, or we need so, we may have to change the membership function. These are the things that is useful for us to create a better system for the fuzzy logic toolbar. So these are all available in MATLAB. You can easily use it, but before that we have to understand the basics I said before, so that we can use it nicely, we can use it more efficiently to Okay, these are the examples of using fuzzy logic for as I said just now, the dinner, using the input of a service and the food as a service. So the service is poor or the food expensive, the tip is cheap. So this is considered as a normal value, cheap 5%. If the service is good, tip is average, is considered as an average value 15%. As a nominal value, if service is excellent or food is delicious, then tip is generous. This is the what you call nominal value for generous. From that we can define our range, and for the membership function, what are the range of values we need to install or put inside the just now we've seen this one. So this is the editor, and from those things we can define the range, and we can simulate the system, which is again it's the same thing. This is the output that we're going to see at the end of the day if we create a .fis format file. Okay, so we can edit it and rerun it again on the MATLAB toolbox.